Hi, good afternoon. Uh, Hopefully this video finds you well, and I'm going to do a brief review of the main ideas in Chapter 7 so far, starting from 7.1 congruence and going through 7.3 similar shapes. So let's get started. First, in 7.1 congruence, we learn that two shapes are congruent when they are the exact same size and the same shape. So what that means is I should be able to take one shape like this triangle here and modify it in some way so that it flips over and can completely cover the other shape. So in this case, triangle ABC is congruent to triangle XYZ. And how can we tell that? Well, I sometimes put my fingers right over the triangle and I sort of flip it around and I try to make sure that the same size and shape would be covering. So the first questions are always going to ask, are they congruent? Are these two triangles congruent? Yes, because they're the same size and shape. The second part of our question will be, what transformations made them congruent? Now, so far, we've learned about three different transformations. Let me scroll down here. We have translation, reflection, and rotation. Remember, translation means sliding a shape or image on the screen. So if I had a circle and I just move that circle to a new spot and it's the exact same size and shape, that would be translation. Reflection means flipping a shape over a line of reflection or mirroring it. And rotation means spinning it, so turning it on its side, going 90 degrees or 180 degrees clockwise or counterclockwise. All three of these changes keep a shape congruent. So let's take a look at one more shape and decide, or back at our triangles, and decide how did they make them congruent and what transformations changed one to the other. Well, in this case, I noticed that side AB here, right here, it looks like it's now on the right-hand side, not the left. That to me means I've got a reflection. In this case, we call this a vertical reflection because it's a vertical line that it's flipping over. Then notice that that doesn't make it perfect. If I flip over this line of reflection, I've now got the triangle about right here. I would then have to translate it. To get it in the exact right location, I would first reflect, then I'd translate. So ultimately, we've discovered what is congruence. Congruence is the same size and shape. And what transformations? Well, that's where we have to choose between our three options. And guys, on this section, almost every problem ends with translation. They always move a shape. So let's take a look at a second example. Try it yourself. Look at these two shapes, look very carefully, and decide, are they congruent? So answer right now for me. Are they congruent? You should have answered no, they are not. Now, it looks like it should have been a reflection here, right over the vertical line, like this. The only problem is this square on the left doesn't quite match with the other shape. It should have been right here, but it's not. Therefore, these two shapes are not congruent, and that's where the problem ends. So now let's take a look at two samples for you to try at home. Problem A. Are these two parallelograms congruent? Yes or no? You should have said yes. Yes, they are congruent. Now, second question would be, what transformations will map image A to image B? There are two. Pick carefully, please. You should have picked a horizontal reflection because we're flipping over the horizon, and then a translation to the left. That would have mapped image A to image B. All right, final problem to check your understanding. Are these two images congruent? You should have picked no. And why not? Well, the shape doesn't exactly match up. Notice that the two bricks here are just one apart. That means this extra one right off the edge would need to be up here in order to really match with the other shape instead of down here. Okay, that covers lesson 7.1. And here are our three main ideas as we've learned: translation, reflection, rotation. All of these keep two shapes congruent. Carrying on, 7.2. So in 7.2, we learn a little bit more about naming parts that are congruent. So now it's not just, are the shapes congruent, but how to name the parts that are congruent. Here's an example. We have two triangles. We have, let me just get my cursor here. Here we've got triangle ABC and triangle DEF. Now, notice that the corners are marked that correspond, meaning corner A is marked with this little arc here, and corner D is marked with that little arc. That means they are the matching corners in the two congruent shapes. Now, how we write that is right here. We write that corner A, or angle A, is congruent with angle D. Remember that our symbol for congruent is an equal sign with a wavy line over the top. That means congruent. So once we have two triangles that are congruent, we have to name all three corners that match. Here, corner B is a right angle and corner E is a right angle. So that means we can name angle B is congruent with angle E. Our last corners that match, notice that F has, and I'll make it a little bigger here for you as best I can, two arcs. And it corresponds with corner C, which has two arcs. Those two arcs is sort of a shortcut of saying, a way of abbreviating and saying that those two corners match up. In this case, angle C corresponds and is congruent with angle F. We can do the same thing with the sides. So we name each of the three sides and we name their corresponding sides. Notice they're marked for us. A lot of times in our book, it's going to show us when there's a single mark. See how there's a single mark between side AB, and there's a single mark here between side DE. That means that those are congruent sides. Those are the corresponding congruent sides. And how we mark that is a little bit different here. Now it's already done here. I'll rewrite it. But if we're going to talk about a side, we're going to use the letters AB, which are the two corners that make the side, but we're going to use a little line above the top. That line segment shows that I'm talking about the line segment. Then I write my congruency symbol, and I would name the other side that matches. In this case, it's ED. Now, we would go through and match up each side. Notice that CB has 2 marks, EF has 2 marks, and AC has 3 marks, and DF has 3 marks. That's what we've listed right here. Finally, we can end a congruency statement with the overall statement about the triangle. Here, what that means is I'm going to say triangle ABC is congruent with triangle DEF. By writing the triangle symbol in the front, you sort of shortcut the word triangle. Also, this gives us a lot of information. The one thing you really have to be careful about is if I write triangle ABC, angle A has to match up. Whatever letter comes first in the first triangle has to match with the corner that matches it in the second. So since angle corner A matched corner D, and I started this triangle by talking about corner A, I have to start the second triangle talking about corner D. Corner B then, I know matches corner E, and corner C matches corner F. So let's try that out for a quick second. I'm going to give you a congruency statement right here, just as a little side note. Here I've got a corner or a triangle, and I'm going to call this triangle HIJ. And I'm going to say that it is congruent with another triangle called DFL. So I want you to tell me what angle corresponds with angle I. You should have come up with angle F. You know that because angle I is in the middle of this name of a triangle, and angle F is in the middle of this name. Let's try one more. How about if I said angle H corresponds and is congruent with which angle over here? You should have said angle D, because it's the first letter listed in both names. This means I don't even need a drawing. I don't need the little triangle drawing and all the markings. All I need is this congruency statement to tell me which letters and which corners match up. Notice that then I can also take that and do it with sides. Watch. HI is one of the sides. What side matches with HI? Well, those are the first two letters of the first triangle, so I'm going to pick the first two of the second. It's congruent with side DF. So why don't you try that? How about if I had side IJ? What side is congruent in my second triangle? You should have come up with FL. So now you try it. Here I have a few triangles for you to take a look at. Or sorry, it's not a triangle, it's a quadrilateral. We have MNOP, and you can see its markings here, and we have ABKS. What side corresponds with MN in this drawing? You should write side AB. That's the matching side based on the congruency marks. Which corner matches angle P in the first picture? Notice that this is a reflection. We have to be careful here, because even though the measurement matches angle K, because it's a reflection, angle P actually matches with angle S. Okay, that concludes lesson 2 on congruence. We could then name the 4 sides quadrilateral. I'm going to go ahead and name them on the left here. Quadrilateral MNOP is congruent with what 4-letter quadrilateral? Make sure your letters match up with the corresponding corners. You should have answered, let's see here, M matches with corner A, so it'd be congruent with corner A. N matches with corner B, AB. K matches with O, so I'm going to say K next. And S matches with P. Oh, yeah. So remember, it doesn't matter so much that this is alphabetical. It happens to be in this problem, but what matters is that the first letter of the first one matches the corner that's first in the second. Okay, we're on to our final problems. And our final lesson from last week. Lesson 3 is on similar shapes. So, what does similar mean? Similar means that it is the same angles, but a different size. That happens with dilation. So if we translate a shape, it's still congruent. That puts it in a new spot. But then if we dilate it, if we make it bigger or smaller by a scale factor, the angles won't change. We'll still have the same corners, the same 180-degree angles in the triangle. But we will have bigger sides, and they should form a ratio. So here's an example. Are these two triangles similar? Remember, similar means they've been dilated. Similar means dilated, not just translated, rotated, or reflected. In this case, yes, they are similar. And how can we tell? Well, I noticed that this side has 4 units, and you can just count the squares, and it changed to this side that was 8 units. That means it's multiplying by 2 each time. And I double check with the bottom. This side is 3 units, and it changed to 6 units. Again, it multiplied by 2. As long as it multiplies by the same number for all 3 sides, we know, yes, it's congruent. So, let's take a stab at that. The best way to do this is really to count the sides and to make a fraction. So what I always do is I label one of them the new shape and one of them the old shape. And what I do is I make a ratio. I always do the ratio new divided by old. So I'm going to take the new shape side and divide it by the old, and I check to make sure, are they the same? When I divide them, they should be if they are similar. Similar shapes will always have the same ratio. So now you try it. Are these shapes the same? Let's try number 1. Are these shapes similar? Yes or no? Now first, we can tell this is translated. It's just moved to the right and down a bit. But are they similar shapes? Your first step would be filling in some numbers here. AD is 2 and AB is 5. EH is 3 and EF is 7. So now we want to make a ratio. These look like the same rectangle. To me, if I'm just using my eyes here, I would say, yeah, they're similar. That would be my guess, because the angles are the same. They're all 90 degrees. But have the sides maintained that ratio? First, let's call this one new and this one old. And let's make the ratio. So the matching side here, 3, matches with side 2. And we'd make a fraction here, 3 divided by 2. That's 3 halves, or 1.5. I can just leave it as an improper fraction, 3 halves. Does that match with the other one? 7 divided by 5? Do they match? Are those equivalent fractions? Your answer should be no. And if they are not, then we know no. They are not similar shapes. Not similar. Because the sides didn't maintain the ratio. Okay, final problem on our video. Are these similar shapes? You should answer yes. If we check the corresponding sides, 6 divided by 3 and 6 divided by 3, we see that they're the same. The second triangle is double the first. Therefore, they are similar. Now, what transformations have occurred? Pick 2. You should have picked a vertical reflection, because here we've got a vertical line like a mirror, that it's flipping over, followed by a dilation. First it reflected, then it dilated. All right, thank you for watching. I hope you're doing well, and I hope that was an overall review from before spring break.